Hello everyone, I'm Eloi and I'm the number 54. Today I will present the project broken. So firstly, I will explain why did we make this code, so the context. Secondly, I will talk about how did we make this code, so the structure. And finally, I will conclude, so give my opinion and and say what this project brings to me. So the goal of the project is to make a code that can rate some damaged beam and stems and tell to the user if we can reuse it. So the code have to tell to the user if we can make a triangle with the elements and precise his nature. So to solve this problem, we'll use a problem of the broken state. So firstly, the code will ask to the user where he wants to make his two bricks in a 400 centimeters brick thick. So for break something, the value has to be higher than 0 and smaller than 400. Otherwise, if the value is too high, so higher than 400, that will break nothing and the code will tell to the user. In the same case, if the value is too small, so smaller than 0, that will also break nothing and the code will also tell to the user. Now we have the two breaks, but we have to define the first segment of the triangle. So one of the segment of the triangle is equal to the smaller breaks. The second one is equal to the higher breaks minus the second breaks. And the last one is equal to the total of the segment minus the higher breaks. Now we have the first segment, but that can be always make a triangle. So for make a triangle, the first segment have to be smaller than their sum divided by 3. If it is, that can make a triangle and the code will continue. Otherwise, that can't make a triangle and the code will tell to the user. So now I will present the three different triangles in this project. So there are the acute triangle. It is a triangle with 3 acute angles, so 3 angles smaller than 90 degrees. The obtuse triangle with 1 angle higher than 90 degrees. And the oblique triangle, it's just a triangle without a 90 degrees angle. Stop. So for each triangle, there are specific conditions are linked with it. So for example, the condition of the acute triangle is a squared plus b squared higher than c squared, a squared plus c squared higher than b squared, and b squared plus c squared higher than a squared. This calculation is for check if you can make a triangle, an acute triangle or not. And each calculation is for check if the angle of the opposite of the segment are acute or not. So that means for the first calculation, if the calculation is true, that means the angle at the opposite of the segment, the angle at the opposite of the segment C are acute. And if the free calculation is true, so that means the free angle is acute and it's an acute triangle. In the same case, in the same logic, we have the condition of the oblique triangle. You can see there are 3 different conditions and a small changement at the first calculation is not higher than, it's smaller than, and this is just for check it is an obtuse angle or not. So now I will explain why there are 3 different conditions. There are 3 different conditions because the obtuse angle can be in the 3 sides of the triangle. So that means each condition are linked with each side of the triangle. So if the obtuse angle at the opposite of the segment A, the condition linked with this case is this one. And now I will talk about the condition of the oblique triangle. The condition of the oblique triangle, like with the acute, they are just not the square. And this condition is for check if we can make a triangle or not. So that means if we can make an oblique triangle, we can't make a triangle. So before I continue, I want to warn you about if conditions are a different level of specificity. So in the if condition, we can't put randomly the condition. We have to put the more specific at the top and the less specific at the bottom. So Now let's talk about the more specific conditions. The more specific conditions are the condition of the active triangle and the obtuse triangle, and the less specific is the condition of the obtuse triangle. We can see in this free chart, that represent all of possibilities that can make a triangle. So an active triangle for the first chart, an obtuse for the second, and an oblique for the last one. We can see in the chart of the obtuse triangle, there are space that represent the space that takes the chart of the acute triangle. So that means if the intersection are here, the triangle will not be an obtuse but an acute triangle. And in the last chart, we can see there are no space. That means the oblique triangle can be an acute triangle and an obtuse triangle. So, is this for this reason the oblique triangle are the less specific condition, the less specific triangle. So, for conclude, the broken stick project bring to me some base of the Python like the if condition or the inverse loop, but they also improve my way of thinking, like on the point of the logistic, with the case of the level of specificity. So, in my opinion, the broken stick project is a really instructive project for learn some base of the Python or just for begin. Although it's a small project, but for me, I think it's a really good project. So thanks everyone to listen me. Don't forget to work on me and remember keep it.
I have a small question. Thanks for your presentation. I believe there's one other type of triangle that exists.
Yeah, we can. There are conditions linked with it. It's a Pythagorean theorem, just for rectangle triangle. Is it?
Exactly. And so if you go back to the slide with all of the equations.
This one?
Exactly. For a right angle triangle, this equation would, maybe not this one. The one with the squares? Yeah, exactly. For a right angle triangle, how would these equations differ?
They are just equal sign without it's not be an higher or smaller, just equal.
I have also a small question about probability.
Yeah.
Do you have any insights on probability then?
I forgot to put a chart, but there are a chart that represents the probabilities in very high, because we make a simulation like 1,000 times, and that's make a probabilities to I think it's 8% to make an acute triangle, 17 for make an obtuse, and 25 for make an oblique triangle. So that means there are 50% chance to make a triangle.